No, duże to.
Inspired, like most young children, by TV heroes.
I was inspired, of course, by science fiction.
I think we all have popular heroes, movie stars that move us emotionally or make us feel heroic. But I think I am who I am today because of my father.
My father was a hero of mine.
Because he protects me when my mother tries to beat me up.
A hero is someone I respect, like my mom.
My hero is my mom, and she inspired me to be a good person. My hero is Shirley Temple.
I think my hero is Winston Churchill. My hero is Dr. Jane Goodall.
Elon Musk.
Take it back.
My greatest hero was my maternal grandfather.
Both of my parents are my heroes because growing up, they taught me that I can do whatever I'm going to do.
They pushed me to be a better person.
Well, everybody that plays into a person's life contributes something and is a hero in some way.
What taught you to be a hero? I just think up to...
You need to be smart.
They'd be brave.
You're what the help people to be a hero. A hero means that you have to be determined and really, really, really want to achieve your goals.
Você consegue ser o que você quiser na vida, desde que você estude, trabalhe, persista e sempre faça mais do que esperam de você.
It takes a lot to be a hero. It takes selflessness, honesty, integrity.
Doing what you feel is right.
Sacrifice, perseverance, and accountability.
Basically, here is brave as can be. I never give up.
Morning class. I think that teachers are incredibly important.
Mr. Miller, by the right teacher, a hero.
These leaders, these people that inspire you, they're everywhere.
Heroes are people who, by their actions and their presence and everything that they do, inspire you to want to be like them.
You need a pioneer spirit and just be willing to push the boundaries of what we can achieve as humans, as people.
Being Canadians, we love Chris Hadfield.
Chuck Yeager's my hero. He's my hero because he's the first man to break the sound barrier.
Tuskegee Airmen, those are the people that sort of paved the way for me with reference to aviation.
And I used to ride my bicycle out to the airport on a regular basis and just sit and watch the airplanes come and go.
My father was Singapore, the Air Corps, then the Air Force, then Reserve.
As I grew up, I had my own heroes. Charles Lindbergh.
Charles Lindbergh. He was, of course, the hero of a lot of young boys in the era that I had grown up.
I think you're probably going to get a similar answer from, I should say, the astronauts who are my age. It was the Apollo program.
Oh yeah, lots of space heroes. Buzz Aldrin.
Neil Armstrong.
When I was 9 years old, we landed at Apollo 11
Y es un privilegio, es algo mágico realmente, esa experiencia, la conexión que hay entre un astronauta y mucha gente.
Belief in myself started with a very small act from a man named Gene Cernan. For many years, he sent me patches from each of the Apollo space missions.
Guys like John Glenn, Gus Grissom, John Young,
Alan Shepard Cook, Wallace Shawn, John Glenn.
In my opinion, he came as an American hero, but he never acted like such.
So those are the types of people that I really admire the most. People that were out on the forefront of exploration, putting their lives on the line.
Those guys are the real heroes.
I was very impressed with their accomplishments.
I can't imagine ever knowing what they do. It's amazing.
They're all the same kind of personalities. They work hard, they set goals, they achieve.
He always helps human beings, so that's the deal.
We choose to go to the pole in this decade and do the other thing. Not because they are easy, but because they are hard.
We're not able to start today. Specific application on the top has T-minus 20 seconds now and counting. All systems go.
Because that goal will serve to organize and measure the best of our energies and skills.
T-minus 20 seconds and counting.
Because that challenge is one that we're willing to accept. One we are willing to postpone. And one we will believe.
Please proceed through the doors ahead and watch your step as you enter. Guests with wheelchairs, scooters, or those who cannot use stairs should stay to the right. Please move all the way to the end of your row to make room for other guests. Once settled, we ask that you put on your 3D glasses. Should you need to leave the presentation for any reason, please remove your 3D glasses and exit through the doors to your left.
I wonder what it was like to be one of those first astronauts.
The 33-ton rocket is poised to hurl America's first man into space at 5,000 miles per hour. Alan Shepard will rocket to 115 miles above the Earth. He will weigh nearly 8,000 pounds and be punishing acceleration of a giant booster rocket.
You know the old desire of all pilots, when you walk up to the airplane, you always kick the tires just to be sure they're not flat. This particular rocket I was never going to see again. So I just stopped as I approached it, looked up into the glare of the spotlights, and took a look at the rocket. Sort of another way of kicking the tires, so to speak.
It's actually getting worse. Power the system off.
We have serious problems here. We already filed enough to enroll at the present time.
The hand control is locked up. We can't turn anything off.
I need him to say he may have a stuck hand control. That's possible. Roger, what about the Agena? Well, he says he is separated from the Agena and he's in a roll and he can't stop it.
Try the reentry control system. It might just give us the correction we need.
Do I understand he's used all the ounce fuel?
His brake pressure is down to 0. His own braking and pressure. Okay, let's work on one axis at a time here. Much better.
We're regaining control of the spacecraft slowly in RCS direct.
Okay, fine, keep at it. We're coming in for dash 3.
I'd like to argue with him, but I don't know. We can't. Command, we will prep for emergency landing at 7-3.
Gemini 8 to have some rescue downwind. The Mason. 3 hours after splash.
The space program was just starting, and when they put out their criteria for the type people they wanted, I seem to have all the qualifications that they were looking for. My combat experience in the Marine Corps in the Pacific was a factor. The Marines were being tossed into some of the toughest combat in early World War II, and then went back out in the Korean War. One people who had worked under stress and duress and had come through okay.
Strike clear of the flight. Still a couple more targets left. I'm taking another pass.
Not a good idea, Major Plan. You'll be a flat magnet again.
Our fellow Marines need us to get this done. I'm going in.
Roger that.
Going low. I'm hit. Still have control. Firing. And I'm on.
Good hit. There's not much left of your tail section.
We're up to that. Let's see if I can make it back to base. Welcome to the Air Force, Major Ken. What do you think about that new F-86 Sabre jet? Well, I think we're about to find out. Ask me again after we take out these pigs. Roger that.
You have to remember my time of growing up in the 1930s. The people of the past, the barnstormers and the people that did their early triumphs in aviation, and one of them, of course, was Charles Lindbergh. They asked me if I would sort of escort Lindbergh down on the beach watching for the launch of Apollo 11.
Over here. It'll be a memorable flight.
Kind of like your first flight across the Atlantic.
The flight I'll remember most is your Apollo 8. The first flight to go around the moon.
Now we're gonna land on that moon.
As I walked with my hero and looked up at that flaming candle taking off for the stars, it all came full circle. A spark of inspiration shaped my career, and my journey took me beyond my wildest dreams to places like the moon. We had just to turn that spark into a flame with the fuel of curiosity. To learn from our failures, never give up until the goal was reached. My heroes and their heroes before them were driven by this notion. So was the entire NASA team when they started this amazing journey into space. Our heroes and legends drive us into the future. Each generation inspires the next to go further into the unknown, beyond our solar system, beyond our galaxy. I can't wait to see where you will go.
Please remove your 3D glass.
Telstar, and it caught the imagination of people all over the world. It was designed to receive signals, amplify, and rebroadcast. A British musical group called the Tornadoes were so excited with this that they wrote an instrumental number called Telstar. Brought it to America, and it went right to the top of our music charts, beating better-known groups such as the Beatles for that privilege. Now, while we were doing this, we were also working with animals. We had selected monkeys and chimps to go out to make sure that they could survive before we put people into our equipment. And our monkeys and chimps were trained in a certain way. The chimps, we had a little panel that had lights and switches on it. And when the light flashed, we trained the chimp to push a button on the light and the button. Then we took the panel and the chimp, put them in a capsule, and we sent them up. Now they were still in the atmosphere, experiencing 7 times the force of gravity when we started flashing the lights. Our thought, hey, if a chimp could get his arm up against all that our astronauts would be pilots and not just passengers. However, again, the Soviet Union said, well, America's trying, but we did dogs a long time ago. We don't see why anybody's interested in these monkeys that are going up now. But as we were working this through, the Soviets also surprised the world once again when they announced that a gentleman named Yuri Gagarin had gone up, gone around, and come home safely. The message from the Soviets, see what wonders we perform as a communist country, come be like us. It was only 20 days after the flight with Yuri Gagarin that we took a little Redstone rocket like the one with the red United States on the side, replaced the warhead with that. We had over 430,000 people working on that program all over the country, but most of them were working temporarily and very contact with various people. We certainly had one of after one launch, suborbital flying on the Redstone, looked at that larger Mercury Atlas combination, and in February 1962, John Glenn had a science to do what was up there. People were saying we don't even know if you can swallow or digest food up there. And so we said, well,
Międzynarodowa Stacja Kosmiczna. Belgia, Kanada, Dania, Francja, Niemcy, Włochy, Japonia, Holandia, Norwegia, Rosja, Hiszpania, Szwecja, Szwajcaria, Anglia i Stany Zjednoczone.
I used to dream about flying through space. Every week on TV, I'd watch my heroes as they jumped into their rocket ships and took to the stars. And I wanted to be like them. They had courage, imagination, and no problem ever stood in their way for long. You know, in the end, when we actually did send men into space, it turned out that those were exactly the qualities it took.
I'm John Hudson. This is Pad 39 of the Kennedy Space Center. I was a launch controller here when from this very spot, man took off to fly to the moon. It was a journey that began 12 years before that rocket ever left the ground. And it started on the other side of the world.
Back then, we were one of 2 superpowers that always seemed to be on the edge of a terrible war. In 1957, the Soviet Union launched the first ever man-made satellite into Earth orbit. They called it Sputnik, which means traveling companion. In a world where peace hung in a delicate balance, it seemed to create a dangerous advantage. Every ham radio operator in America could hear it beating. People were afraid. Were the Soviets looking down on us, watching us? If they could make a satellite pass over our cities, could they do the same with a bomb? Our own space program kicked into high gear, and less than 2 months later, we were ready to launch our own satellite. It was being called the space race, and we were running a distant second. In 1961, we fell even further behind. Soviet cosmonaut Yuri Gagarin became the first man into space, circling the world in just 89 minutes. We had our own astronauts, and they were eager and ready to take the big ride. But our manned space program couldn't seem to get off the ground. We stuck with it, and on May 5th, 1961, things finally started going right. astronaut Alan Shepard took his ship Freedom 7 6.5 miles into space. America had its first space hero. Just a few days later, our space program received a new challenge. But this one did not come from the Soviet Union. It came from our young president. In one inspiring moment, he changed the mission from one based in fear of the present to one of hope for the future.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why 35 years ago, fly the Atlantic? Why this rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
We hadn't been more than 16 minutes into space, and now we were going to the moon. We would have to design a rocket the size of a 36-story office building, put it together with the precision of a microscope, and accelerate it to the speed of a bullet. Then we would have to guide it to a moving target 250,000 miles away. Many people thought it was an impossible dream, but 400,000 of us set about making that dream a reality. It would be the longest, most hazardous voyage that any man had dared to attempt. But step by step, mission by mission, we orbited the Earth, perfecting the skills and technologies we would need on this incredible journey. Our astronauts practiced maneuvering, docking, and the 1,000 other tasks that would comprise the moon mission. We created new alloys, lighter and stronger than anything seen before. We designed communication systems that would be reliable over the vast distances. And behind it all, we tried to perfect the rocket that would be powerful enough to punch out of Earth orbit and take us to the moon. One day, however, the dream of flying to the moon almost slipped away. It was January 27th, 1967. Astronauts Virgil Gus Grissom, Edward White, and Roger Chaffee were on board Apollo 1 for a plugs-out test, a full-scale dress rehearsal for the actual launch. Suddenly it happened. There was a fire in the capsule. 3 men whose lives had been in our hands were lost.
Surely the opening vistas of space promise high costs and hardships, as well as high reward. But this country of the United States was not built by those who waited and rested and wished to look behind them.
After Apollo 1, some thought we'd failed, and that the moon was out of our reach. But we owed it to those men, to learn from their sacrifice, and to carry on. We started taking the Apollo vehicle apart piece by piece. Was the design flawed? Had safety been compromised? Tough questions. And we spent 1.5 years redesigning the spacecraft so that no astronaut's life would ever be at risk because we overlooked something or because we could have done something better. A moon rocket is 91% high explosive, and it goes into the most unforgiving, hazardous environment there is. We could never make it risk-free, and the men who flew them knew that. We didn't send men into space again until Apollo 7 orbited the Earth testing some of the new designs. When everything worked perfectly, the decision was made. The next mission would travel to the moon. It was mankind's destiny to leave the shores of our planet behind and strike out across the vast ocean of space. In the great span of our history, now was the time that we could. Now was the time that we would. We stood on the eve of the longest, most dangerous journey that any man had ever undertaken. And it would be taken by Frank Borman, James Lovell, and William Anders, the crew of Apollo 8. Through those doors, you'll find the firing room, launch control, just as it was on December 21st, 1968.
Please gather all of your belongings. Take
Apollo missions. This is not a mock-up. These are the very consoles we sat at when men first took off to fly to the moon. The tragedy of Apollo 1 had put us a year and a half behind. We were making up for it in one big leap, and we were doing it with a rocket that no man had ever flown before. It was a few days before Christmas 1968 when Apollo 8 sat on the pad. She was the first of a new kind, a moon rocket. This was the Phoenix, risen from the ashes of Apollo 1. The first Apollo crew did not die in vain. This was to be their testament. Stories high, she had been fully fueled throughout the night. The liquid oxygen in her tanks caused ice to form on the outside of the craft. The extreme temperature differences between the air and the sub-zero fuel caused the metal skin of the rocket to expand and contract. Everyone who was on the pad agreed. It was as though the rocket was alive, breathing, straining at the leash. Earlier in the morning, astronauts Frank Borman, Jim Lovell, and Bill Anders had made their final preparations before taking that long ride out to the waiting spacecraft. The minimum safe distance from a Saturn V at liftoff was 3 miles. The reason was simple. When fully fueled, the rocket contained the explosive power of an atomic bomb. As the clock counted down, the astronauts and all of us in launch control went through the pre-flight checks. Our hands on the controls of the most powerful, most complex machine ever built. It had over 2 million separate systems, and to bring these men back alive, everything had to work perfectly. Each individual system had been tested, but what we didn't know was how they would perform when all 2 million began to work together. That moment would come when the countdown clock reached 0. If a maneuvering thruster failed, if communications broke down, if navigation was off by 1 degree, if any piece of the miles of wiring, circuits, relays, or valves was defective, Frank Borman, Jim Lovell, and Bill Anders would pay with their lives. As they sat, waiting for launch on that chill December morning, these 3 astronauts were back to what they had always been, test pilots. You are now in the final minutes before the launch of Apollo 8, right here where it actually happened. Mankind is about to leave his planet behind and journey to another. It is one of those rare moments when history is not being made, destiny is being embraced.
This is Launch Control, T-minus dashboard indicates that all aspects are ready. Instrument unit is ready, spacecraft ready. Final check of the emergency detection system. That ready light also on. First stage preparations are completed.
All systems remaining okay.
Okay, keep going. We're on. Ready to go to concrete. Stand by motor. Okay, you're on.
All systems go.
T-minus 45 seconds and counting. First stage liquid oxygen tank has been pressurized and the pressure is still building up. Coming up on 90 seconds, mark T-minus 90 seconds and counting. The Apollo 8 crew standing by, spacecraft commander Frank Warren, Jim Lovell, Bill Anders. And now we report that the liquid hydrogen tank in the third stage is pressurized. 1 minute 15 seconds. All third stage propellants pressurized at this time as we come up on the 60-second mark on the flight to the moon. T-minus 60 seconds and counting. The vehicle now is completely pressurized. We're coming up on power transfer shortly. We have the power transfer. We're now on the flight batteries within the launch vehicle. Final reports coming from Frank Borman at this time. Final look at the switch list aboard the spacecraft. 20 seconds, all aspects may have still rolled at this time. 15, 14, 13, 12, 11, 10.
Apollo 8 successfully orbited the moon, and the astronauts returned safely to the Earth. I know. I'm Jim Lovell, and I was one of the crew of this spacecraft, Apollo 8. We were the first men to see the surface of the moon from just a few miles away. But it was the hundreds of thousands of men and women who worked in that team, and the millions of people who supported the mission that really made it possible. That way, I guess, we all went to the moon. Now, on the other side of those doors, you'll find an actual Saturn V moon rocket. It's still the most powerful, the most complex machine ever built. And I guess it's the only one that can take you to another planet. I actually got to fly one on a second flight to the moon called Apollo 13. But that's another story.
Building 36?
I didn't even know there was a building 36. Must be important. Everyone's here. We got propulsion, aerothermal, flight dynamics.
Anyone know why we're here?
For this.
Good morning. We're going to create America's next spacecraft. It's going to launch like a rocket and land like an airplane, and it's going to be reusable.
Can't do that with a rocket.
It's not a rocket. It's a shuttle.
Now it's time to go to the next step. Sketch pad to launch pad. Going to the moon was a camping trip. Now our job is to work and live in space. This vehicle has to do something that we have never done before. Perform 4 key tasks and be able to do them over and over again. There is nothing easy about putting a ship back up into space, let alone a whole fleet of ships. But first, let's talk about the launch. We have never designed engines and vehicles that can be reused. But we will, and once we're in orbit, we go to work. We want to take all kinds of cargo up there in addition to the people. Science labs, satellites, even the space station. And when all the work is done, we gotta bring everybody back home. All right now, the country's waiting. Let's build ourselves a space shuttle.
It's too big, it's too heavy. But we're launching one spaceship on the back of an even bigger one.
What if we split the booster into its pieces? Rockets, fuel tank.
It's supposed to be reusable. How do we get all those parts home?
What if we just throw the fuel tank away?
We're running all new processes, procedures, manuals. We've never had to reuse a ship before.
We're also going to have to build some really big garages.
Sir, what if she lands somewhere other than Florida? How'd she get back here? It's a glider.
Buy her a plane ticket home. Ablative heat shields are heavy, and they burn up on re-entry. We need a more reusable solution. Silica foam tiles, thousands of them, fitted together in one lightweight, reusable heat shield.
Another hold up with the engines? Tell me some good news with the tiles.
The heat shield bond keeps failing. The tiles keep falling off.
So another delay. How long? How long?
1.5 to 2 years.
Well, this is going to be fun to tell my boss. Everybody get back to work. let you know. And they come home.
The President's message said you go forward this morning on a daring enterprise and you carry the hopes and prayers of all Americans with you. And astronaut John Young, the commander of the mission, replied, "That's a right fine speech. We sure appreciate it."
And we have liftoff. Whoa, way too fast. The shuttle has escaped Earth's gravity completely and is traveling into deep space. Try again.
Person to stand on Mars might be in our audience today, because today's young people.
Richard Castellanos, I'm a communicator here with the Kennedy Space Center, and today we're going to be taking a tour through our solar system. When we talk about the very beginnings of our solar system, we have to start a long time ago in a galaxy not so far away. In fact, our very own Milky Way galaxy that you're looking at here. And in our galaxy, a long time ago, a star was born. This was an average-sized star, not too big, not too small. It would be classified as a yellow dwarf star. And that star was born when a big cloud of gas began to condense. Gravity pulled the gas molecules closer and closer together, and it got denser. And it got so dense that it started a nuclear fusion reaction. That reaction has been going for billions of years, and it's going to continue for billions more. Now, while that star was being born, there were other clouds of gas orbiting the star, and they began to condense, but they condensed into smaller particles. Well, gravity attracted those particles together, and they got bigger. They became rock-sized, and then boulder-sized, and gravity attracted the boulders together, and 99% of all the matter in the entire solar system is right here in the sun. And the sun is so big that you could fit 1 million planet Earths inside it. Our sun is mainly made of two elements, hydrogen and helium. And I think you already know that the sun is about 93 million miles away from the Earth, but did you know that it takes light about 8 minutes to get here from the sun? Now these white flashes that you've been seeing on the surface, these are solar flares. They send charged particles millions of miles out into space. They create what we call space weather. Now, if one of those flares happens to be pointing towards the Earth, when it erupts, it can disrupt our satellite transmissions and radio broadcasts, but they also cause the really cool light shows that people see, especially people living in the extreme northern and southern latitudes. And of course, we call those the auroras. So we're going to get into an imaginary spaceship. We're going to start heading out away from the sun to our first location. And let's see if anybody here happens to know what this is. Now, I'm going to give you a clue. It is not the moon. It's not the moon. Anybody have an idea? Mercury. That's right. This is the planet Mercury. Now, look at all those craters. Why does Mercury have so many craters? It's because Mercury has no atmosphere. We have meteors and meteorites whizzing through the solar system all the time. Hundreds of them come into the area of Earth every single day, but almost none of them get down to the surface. Why not? They burn up in our atmosphere. But because there is no atmosphere around Mercury, nothing to slow those meteors down, they just slam into the surface, and the largest of them cause the craters. Now, Mercury is the closest planet to the sun. It takes just 88 days for it to do one full orbit around the sun. So a year on Mercury is the same as 88 of our days. But a day on Mercury is very slow. It takes 58 and a half of our days for Mercury to rotate once on its axis. So think about this. If you lived on Mercury for 2 years, you would only experience 3 days. How weird is that? But you wouldn't be living on Mercury. There's that little matter of no atmosphere. It means you can't breathe there. The other reason is the temperatures. The side of Mercury facing the sun gets up to 800 degrees Fahrenheit. And the side away from the sun gets down to minus 270 degrees Fahrenheit. Not exactly a pleasant place for humans. So we're going to get back in our rocket ship. We're going to head out a little bit farther to our next location. And does anybody happen to know what this is? Venus. That's right. This is the planet Venus. However, if you looked at Venus through a telescope, it wouldn't look anything like this. Because Venus is completely covered with thick, dense clouds and a thick atmosphere that's mainly made of carbon dioxide. We use radar to pierce through the clouds to show the surface features of Venus. And the white areas you're seeing over here, these are just higher elevation areas. Now, when I was growing up, scientists used to say, someday we're going to colonize Venus. And it made sense at the time, because Venus is almost the same size as the Earth. It's just a little bit smaller. But we've learned a lot about Venus since then. There's no way we're going to colonize this planet. For one, those thick clouds that cover the whole planet, they are made of sulfuric acid. And the temperatures on Venus are even hotter than on Mercury. This is the hottest planet in the solar system, with temperatures getting up to 860 degrees Fahrenheit. That is hot enough to melt lead. Think humans would do well here? No way. All right, so we're back in our rocket. We're heading out farther, and I know you're all going to recognize our next location. Yeah, because it is our home, right? With all of the blues and greens and yellows and browns and all the wispy white clouds. And one or two of the astronauts that have gotten away from the Earth, and they look back on it, they say, you know, it almost looks like a blue marble. Well, the emphasis is on the blue, because Earth is the one planet in our solar system that has an abundance of liquid water. 70% of Earth's surface is covered with water, and that is good for us humans, because water is a requirement for any kind of life that we are familiar with. Now, Earth is the first planet away from the sun that has its own moon. Yeah. Now, our moon is kind of unique compared to other moons relative to their planets because it's so big. Our moon is a quarter of the size of the Earth. It's big enough to cause our oceans to slightly rise and fall a couple times every day. And of course, we call that the tides. Now, there's one side of the moon that always faces the Earth. We can only see one side of the moon from here. The reason for that, the mass of the moon is not evenly distributed. There actually is a heavier side of the moon, and it's that heavy side that always faces the Earth. All right, we're back in our rocket ship. We're now heading beyond Earth's orbit to our next location, and who knows what this is? Mars, of course. Now, Mars is smaller. It's only about half the size of the Earth. It does have an atmosphere, but it's a very thin atmosphere. Again, mainly made of carbon dioxide. Now, there's a couple cool features on Mars that I want to show you. I'm going to start over here. Mars has the deepest canyon we have ever found anywhere in the solar system. That canyon is called Valles Marineris, and it is 4 miles deep. Now, let's put that into perspective. Our Grand Canyon here in this country is only 1 mile deep. This is a very deep canyon. I'm going to bring it over here so you can see it. Valles Marineris. The length of this is about 2,500 miles. So imagine a 4 mile deep canyon running between New York and Los Angeles. That'd be pretty cool, wouldn't it? Well, Mars also has the tallest mountain we have found anywhere in the solar system. That mountain is called Olympus Mons. It is an extinct volcano that is 3 times the height of Mount Everest. I'll bring it over here so you can see it on this side. Olympus Mons, 3 times the height of Mount Everest. Now, we currently have an active rover on the surface of Mars. That rover is called Curiosity. It's been working on Mars for almost 7 years. We also have 6 active satellites orbiting Mars right now, and it's the data from the satellites and the rovers that led our scientists to conclude Mars used to have a lot of liquid water on its surface. What happened to that water? Where did it go? Well, has there ever been life on Mars? Well, we're still exploring, so stay tuned. All right, we're back in our rocket ship. We are heading out much farther now. We're moving through an area called the asteroid belt. That is a band of millions of rocky objects that fall between Mars and our next planet that just happens to be the largest planet in the solar system. So who knows what this is? Jupiter, that's right. Jupiter is what we call a gas giant. It's really big, and that surface that you see is not solid. That's all clouds. If you tried to stand on that, you would fall right through. Now, we do think that there is a solid or a semi-solid core in the center, but we've never seen it. The most famous feature on Jupiter, of course, is the big red spot. That is a hurricane that we believe has been going for at least 300 years. Yeah, imagine a hurricane here on Earth lasted for 300 years. That would be a little below average, especially if your house was underneath it. Well, that red spot is so big, and I'll bring it over here, that you could almost fit 2 planet Earths inside there. That kind of gives you an idea of how big Jupiter is, right? Now, I'm going to show you a quick little movie. This shows some of the movement of the clouds on Jupiter. When you get closer to the equator, those clouds move in bands. That's your jet stream that moves in a straight line on Jupiter. And those bands move in opposite directions to each other. Very dynamic, very turbulent weather always taking place on Jupiter. As of last count, Jupiter has 79 moons. Think about that. We have 1 moon orbiting the Earth. Jupiter has 79 moons. One of those moons of particular interest to scientists is called Europa. And the reason we're so interested in this moon, we believe there is a liquid ocean underneath this icy surface. The surface is all ice. So NASA is already planning on sending a probe to orbit Europa. And then possibly, a few years later, sending a lander, something that might drill through that ice to get to the liquid ocean. We're back in our rocket, heading out even farther. Now, this next planet is going to look a little different than the way you normally see it. See if you can tell me what the planet is and what's missing. So who knows what the planet is? Saturn, and of course what's missing? The rings. Why no rings? Our software can't display them out in open space. So again, Saturn is a gas giant like Jupiter. It's a little smaller than Jupiter. Oh, and by the way, those rings are not solid. They're made of billions of icy particles. Some of them are as small as grains of sand. Some of them are ice boulders as big as houses. But when you look at the picture of the rings of Saturn, just know they're not solid. Now there's another cool feature on Saturn, and that is its north and south poles. So I'm going to tip Saturn over on the side. So over here, you all are now looking at the North Pole, right? And over on this side, you're looking at the South Pole. Well, that South Pole kind of looks like an eye, doesn't it? If it blinks, let me know. The North Pole has this unusual hexagon shape. We know that's being formed by air currents moving at about 200 miles an hour, but we don't know why it's making that particular shape. Now, to show you how different the two poles are, I'll spin Saturn around. So now, over here, you're looking at the North Pole, and over here, you're looking at the South Pole. Why are those two so different? We don't know. We have no idea. Saturn has over 60 moons, and the largest of those moons is called Titan. And the reason we're so intrigued by Titan, it is the only moon we have found in our solar system that has an atmosphere. So again, we use radar to pierce through the clouds to show the surface features of Titan. And some of these really dark areas that you're looking at, these are liquid lakes. The only place other than here on Earth we have ever found liquid lakes. But don't be putting your swimsuits on just yet, because these lakes are not filled with water. They are filled with liquid methane. So imagine swimming in something that's kind of like gasoline. You think that'd be fun, swimming in gasoline? Yuck, no way. All right, we have one more moon that we want to look at. This moon is also around Saturn. And this is, wait a minute, that's no moon, it's a space station. Who put that there? How did that get there? Sorry about that. All right, every planet that you've looked at so far are planets that you can see with your naked eye. If you know where in the sky to look and at what time of year to look, you can see Mercury and Venus and Mars and Jupiter and Saturn. But now we are getting to planets that are so far away, the only way you can see them is through a telescope. This is the planet Uranus. Again, it's a gas giant like Jupiter or Saturn, but because it's so far away and it's so cold there, we sometimes call these next two planets ice giants. The unusual thing about this planet is the way that it rotates on its axis. Most planets have an axis that either runs straight up and down, or, like Earth, on a slight angle. Well, something happened to Uranus a long time ago. It got knocked on its side. So it rotates like this. You can imagine a barrel rolling along the ground. That describes the rotation of Uranus. Very unusual, very different than any other planet in our solar system. But now we're moving even farther out. And does anybody happen to know what this is? This is Neptune, that's right. Again, it's a gas giant or ice giant. Neptune is so far away, it takes 165 years to do one orbit around the sun. And it's so cold there that we think this pale blue color is caused by frozen methane in the atmosphere. Frozen methane. Now I have one more object to show you. When I was growing up, this next object was called a planet. But today it has been reclassified as a dwarf planet. So who knows what this is? Pluto, that's right. Now Pluto, of course, is much, much smaller than those gas giants. In fact, you could fit the diameter of Pluto within the United States. And it's solid, it's not gas. Up until about 4 years ago, we didn't have any good pictures of Pluto because it was so far away. The best we had were from the Hubble Space Telescope, and they came back with these blotchy shapes like you see over here. But 14 years ago, we launched a probe from here at the Kennedy Space Center called New Horizons. 4 years ago, that probe flew by Pluto, giving us our first close-up pictures of Pluto's surface, like what you're seeing over here. And our scientists were absolutely amazed. We thought Pluto was going to be a dead, rocky world, but it's not. Pluto is still very active geologically. It has 11,000-foot tall mountains that are made of ice. And the ice on Pluto is as strong as steel is here on Earth. Pluto also has actively moving glaciers. This white area up here that kind of looks like a heart, these are glaciers. They're moving. But these glaciers are not made of water ice. They're made of frozen nitrogen. Pluto is located in an area called the Kuiper Belt. That is a band of billions of icy objects. We think most of them are smaller than Pluto, although we have found one that's about the same size. Oh, and by the way, that New Horizons probe is now well past Pluto. It's going deeper into the Kuiper Belt. Just last January, it encountered another Kuiper Belt object and sent us pictures back of that object. So as I leave you with one final slide, and this slide shows the relative sizes of the planets to each other and to the sun, with all of our probes and landers and rovers and satellites, we have determined that our solar system is a fascinating place, much more so than we could have ever imagined even just a few years ago. So there's our brief tour of the solar system. I hope you enjoyed it. If you have any questions, I'm going to stick around for a couple minutes. I'm more than happy to answer your questions. Please enjoy the rest of your day here at the Kennedy Space Center. Thank you so much for being with us today. Thank you.